Enterprise data infrastructure has become a massive, slow-moving vessel, weighed down by layers of complexity and struggling to navigate rigid constraints. Formats like Apache Iceberg and Delta Lake solved critical problems for managing data at scale, but they brought along heavy infrastructure requirements and operational bloat. Duck Lake was designed as a lean alternative to those heavyweights, aiming to reduce that complexity. Yet, a pervasive misconception persists among data engineering teams. Many assume this new tool requires a mandatory connection to the commercial platform, MotherDuck. This assumption introduces a specific technical tension. For a practitioner, an open-source tool that requires a proprietary cloud service creates a dependency that effectively bypasses the primary benefits of an open standard. Looking at this system diagram of the industry's common assumption, we see the open-source specification and the commercial platform fused into a single monolithic dependency. The reality of the architecture is entirely separate. Duck Lake is a fully standalone open-source table and catalog specification that operates independently of MotherDuck. To understand its value, we have to strip away the cloud layer and reconstruct the architecture from its foundational components. We start with a clean slate, a purely local laptop or self-hosted server environment, disconnected from the cloud. The first requirement of any data lakehouse is defining how it physically stores raw analytical data. Duck Lake relies exclusively on the standard Apache Parquet format for its storage layer. In this foundational bottom layer, the data resides in these standard Parquet files. These files do not require a proprietary cloud. They can sit directly on a local disk or in standard cloud storage buckets. To process these files, we introduce the compute layer, the open-source DuckDB query engine. Users interact directly with this engine by using standard SQL commands to query their data. An engineer can execute these queries from their own machine, sending instructions through the engine directly down to the Parquet layer. While we have open storage and local compute, a true table format needs a mechanism to track and organize those raw files. By grounding the bottom layers in components like Parquet and local DuckDB compute, Duck Lake avoids proprietary storage traps and allows for complete control. The critical missing piece is the metadata catalog. Heavyweight systems often require complex, dedicated services just to track which files belong to which tables. Duck Lake manages its catalog by attaching to standard, everyday relational databases. This metadata layer is slotted in between the compute engine and the raw data. The catalog is flexible, allowing the use of a local DuckDB file, SQLite, or PostgreSQL. This allows you to map your metadata catalog to whichever lightweight database already fits your self-hosted setup. The relational database acts as the system's brain, mapping exactly to the raw data files in the layer below. This specific combination, relational metadata managing Parquet files, is what defines the Duck Lake specification. This fully functional stack is open source, released under the permissive MIT license. It was created by DuckDB Labs, the same team responsible for the open source query engine. Replacing a complex standalone metadata service with a standard SQLite or Postgres database makes Duck Lake lightweight and independent of specific infrastructure. If the architecture is fully functional locally, we have to define where MotherDuck actually fits into the picture. MotherDuck is a commercial, cloud-managed platform, separate from the open-source specification. In our diagram, MotherDuck appears as an external add-on, connected by an optional link. It offers services like hosted Duck Lake infrastructure and serverless cloud deployments for those who choose to use them. While MotherDuck simplifies background management for enterprise teams, it is not a requirement to run the software. Removing the commercial module from the equation leaves the standalone Duck Lake stack fully operational. Because Duck Lake uses standard SQL for metadata and Parquet for storage, users retain full ownership and control of their data. This provides the performance of a modern table format without requiring a specific vendor's infrastructure. Duck Lake operates as a modular lakehouse. It provides the necessary analytical power while leaving the decision to scale locally or migrate to commercial management completely and entirely to the user.